Okay. Ooh, and let me put the projector on too. I forgot to do that. Take just a minute or two for that to come up. Let me get the slideshow set from the current slide, and we'll start from there. Okay, what you got?
What I'm saying is, every time I do some problem, I stop at some point.
Okay.
I can't go no further. So, I don't know, you can help me again or not. So, that's why I can't finish this quiz.
Okay.
Because I'm so sorry.
Okay. Can you find the problem similar to it in the book?
Yeah, but the problem is different, like the way the problem is given.
Right.
Like, you remember the problem that 5b, like ex and ex to the ex.
Okay, which one are we talking about now?
5b.
5B? Okay.
So,
All right.
I let the u equal
Let
to
me get Marcus here. Okay. This is 5B. Oh, let me get my pen set up. 5B. The integral from 0 to 2 of e to the x, goodness gracious. I got way, oops. All right. I was looking at my paper and not at where I was writing. E to the x dx. Okay? Now, that's the problem. What's your question?
okay, I did let the u equal to e to the ex.
Okay, let me hear that again.
Let the u equal to e to the
No.
ex.
Have u be the innermost part of the most complicated looking part here. Well, you have this and that. Here's more complicated, right?
Yeah, that is the one I use.
Then use the innermost part. Let it just be e to the x.
Oh, I don't have to use the okay. Oh,
Try that.
okay.
Yeah.
Oh, I got that.
Okay. Alrighty. Any other?
Okay, then C.
On that same 5C?
5C.
Okay. Okay. What about it?
Okay, I think what I did is I think I did wrong because let the u equal e to the sine
No.
x. So I supposed to do sine x.
Just sine x. Yeah.
That's right.
Okay.
Okay, I got that.
Alrighty.
And okay, 7b.
7B. Okay.
So 7b, what I did is can I show you the
Okay.
way I did?
Okay. Alright. Like the way, okay, now. This is an x cubed here, and that should be an x cubed there.
No, I got the like you did before. Like I take the
Oh, I
x
see
and
what
then
you did. Right,
brought
right,
the
right, right.
x to this side,
Right, right.
and then I came up with this because x square equal to
Right, got
1 minus q.
Right.
Then I have to take the entire derivative, right?
Okay, that's just, alright. So x squared is equal to 1 minus u. Yeah, okay.
So then the next step is I have to take the antiderivative.
Okay. Not yet.
Not yet. Oh,
Multiply,
I can
distribute.
distribute and
Right.
then take the antiderivative.
Yeah, right.
Okay. I think I can try that.
Okay.
So, and 8.
8. 8A. Integral from 1 to e of log x dx over x times the square root of 1 plus log squared x. Yeah.
So I let the u equal to the innermost part, which is n.
Okay, wait. Let u equal
1 plus ln squared s. Yeah.
Is that what you let it equal?
Yes.
Or the square root of that?
Oh, I didn't use the square root.
That's what you're supposed to do right there.
And then du
Right?
equal to 2ln
Yeah. Okay. 2
um,
ln of x.
x 1 ox.
Okay, times 1 over x. So I'm going to keep it from being confusing. I'm going to put the 1 over x out front.
So if I take the 2 over x to the other side.
Okay, not the 2 over x. Just take the 2 to the other side. Divide both sides by 2.
What happened to the okay?
Leave the x there because you see then your du over 2 is ln x over x, and that's exactly what you got here. Ln x over x here, dx. You need the dx over there.
Okay, then how do we write the
Wait a minute. Okay, yeah.
and how do we write the next part with using u? Like,
Okay. Well,
what?
what you have then, now you'll need to change your limits. Your limits for x are 1 to e, and your u is equal to 1 plus log squared x. So when x is 1, that's 1 plus, what is the log of 1?
1.
No, log of 1 is 0. ln of 1 is 0.
Okay.
Try that, okay? So that would be 0 squared is 0, so that would be going from 1 to, and when x is e, what's the log of e? Log of e is 1, because that's the base for your natural logarithms. Right? Okay? And 1 squared is 1, okay? So 1 plus 1 is 2. So that would be going from 1 to 2. Now you have the 1/2 out in front because of this 1/2 here. So that 1/2 out in front. And then this part here is your du. Once you pull the 1/2 out, your du is log x dx over x. So that part is your du, and this part would be the square root of u, because u is the same. So that would be yeah. Okay. So this, I'm going to do it up here because I don't have room down there. This will be the limit. Now, I think we said it was from 1 to 2, right? For u's. Okay, you have the 1/2 out in front from here, right? Okay, and then what you have is du in the numerator, because your du with the 1/2 out in front is log x over x dx, which is exactly this part right here. So that's your du, right? And then what you have down here is the square root of u, exactly. Okay? Now, before I would try to solve that, I would write it as 1/2 the integral from 1 to 2. I hope I got those limits right. I think I did. It's really slow happening. I'd write this as u to the minus 1/2 du. Square root of u is u to the 1/2. And since in the denominator is u to the minus 1/2, then you do your antiderivative from there, right? And it's not a pretty number. You have a square root of 2 in it, but that's fine. That's still a legitimate answer. Does that answer your question on it?
Yeah.
Okay. You got it too? You understand? Marcus, are you seeing? Okay. B. Okay. The integral, I can read that, from 1 to e of the cube root of log x over x dx. Okay, let u equal ln x, I agree with that. Then du is equal to, what's that? 1 over x dx, right? Yeah, there's your 1 over x dx right there. That's your du now. So one thing you got to do is put in your limits here. So this in u's will be when x is equal to 1, log of 1 is 0. And when x is equal to e, log of e is 1. Okay, so there's your new limits. And you have the cube root of u, right? That's your log x is u, du. Now, I would just rewrite that as 0 to 1. The cube root of u would be the same as u to the 1 over 3 du. Yeah, I would go from there. Right?
What about
9A. I'm going to have to clear the page. Is that okay? Still writing some of that? Got it? Can I erase it? Have questions about any of that? Okay. All right. 9A. Calculate the definite integral 0 to 1/3 inverse cosine of 3x plus x over the square root of 1 minus 9x squared. Okay. Somewhere there's a dx there. Okay. Right.
So what I do, I would do like, let the u equal to 1 minus 9.
Okay. I would say not on this one. The most complicated part of this to me is not the square root in the denominator. Most of the time that would do it. But the most complicated part to me is that inverse cosine. So I think I would go with that and see what the derivative of the inverse cosine is. Now you'll go, I don't know if you remember those. I tend not to remember those. So in the back of the book, on your differentiation page, you got a bunch of integrals at the very back, and just keep on moving forward until you get to that page that says differentiation. It's on the right hand side, opposite the page that says exponential and logarithmic functions, hyperbolic function, inverse hyperbolic function, the differentiation. You see that page? Okay. And go down to inverse trigonometric functions and see number 20 down there, d by dx of inverse cosine of x. So if you let u equal inverse cosine of x, then du is equal to minus 1 over the square root of that, and I think you see that's pretty much what the rest of it is. That's what I would use.
Okay, then how we use that to that problem? How will I get together?
Okay. Now, you also have a little bit of chain rule here, so you could do 2 substitutions, or you could just leave it as 1. It's up to you. You want to use inverse cosine of 3x, or you want to do a substitution, make it u, and then do inverse cosine of u. I think it's pretty straightforward to say let u equal the inverse cosine of 3x, right? Then du is equal to, and this is where I go to the table to make sure I don't make a mistake here. That would be, what do you see it as? If that's your u, what is du? Looking at that, it's what? Negative 1 over the square root of 1 minus, okay? Now here you would put in your 3x rather than x, right? Because this thing in the book is for x. So 3x would be 3x squared, which would be 9x squared, right? Then you'd have to use the chain rule on that to do a derivative of 3x would be 3. So I'll put that 3 up in the numerator. And then this would be a dx. Okay? Now, situations we have here, your du is the thing that you have up here. This part right here looks a lot like this, except for the minus 3. So you'd have to divide both sides by minus and divide both sides by 3. And you have minus du over 3, blah, blah, blah. Okay. So then it looks like to me, and let's see, here's a little bit of an issue here too. If when x is equal to 0, we're going to be changing our limits here. And this will be the integral in u's, because you're going to use du's now. You have a minus 1 over 3 from here, right? Okay. Got it? Agree? Okay. Now, let's change our limits. When x is equal to 0, what is the inverse cosine, and 3x would then be 0 also, inverse cosine of 0? What's that? Pi over 2, exactly. Okay? Wait, is that right? Okay. Inverse cosine, I think you're doing sine. No, you're right. Pi over 2. Pi over 2. Okay, sorry. Okay, now, when x is equal to 1/3, 3x would be 1, and what's the inverse cosine of 1? Zero. Very good. Okay. Now, what you have inside here is u is that thing, inverse cosine of 3x. Whoa, goodness. We have a plus x there I forgot about. Yuck. Oh. All right, we got to do this in 2 pieces. I forgot about my plus x. Okay, we're just doing the first part. Okay. All right. So this will be, let's forget about the plus x for now. We'll come back and pick that up in just a second. Okay. All right, that would be u, and that's u du. Okay, all right. Then, not having changed this, we'll do a plus the integral from 0 to 1/3 of x over the square root of 1 minus 9x squared dx. Now this one you do like you were starting to do before. Let this down here be your u. 1 minus 9x squared be your u. Yeah, the x over this you do separately.
So then after we get the x, what are we going to do?
You add them together. I mean, you do a new u, or you can change it to v if you want to. For this one, this will be.
We take that into under the.
What's that again?
Okay. We take that x part until the result of that u, and then add into the other u, right? You know what I mean?
No. Where are you now? Are you on the second integral? Or where are you? Up there or down
No,
here?
I was just asking. I haven't. Okay. Yeah, the second integral.
That one there.
Yes.
Okay.
In second integral, somehow we have to come up to u, right?
Right.
After we get the u.
What is the u?
I don't know.
It's what you were suggesting to begin with.
The u is going to be 1 minus x squared.
1 minus 9x squared.
Yes, 9x squared.
And then du.
Du is going to be minus 18x.
Yep, perfect. Now,
And then divided by negative 18.
yes.
Both sides.
And there's also a dx out here. Okay, got it.
And then we
So let's keep up with what we're doing now. Let's do the first integral. Notice there's a minus out in front of that, but your limits are going from large to small. And to flip those, you'd lose the minus sign, right?
Yes.
Okay. So let's do that before we write the next step down. 1/3 the integral from 0 to pi halves of u du. Right? Okay. Plus, okay, the integral, making that substitution, let u equal 1 minus 9x squared. When x is equal to 0, what's u? Yeah. When x equals 0, 1. And when x is equal to 1/3, 1/3 squared is? Okay, yeah, 1/9. And 9 1/9 would be 9/9, so it would be 1 minus 1, which is 0. Oh, but we also, I put the plus here, but that really isn't a plus. That should have been a, yeah, it should have been a minus 1/18. Remember? We had that out in front. Okay? And now this would wind up being, with that out there, your x dx is negative 1/18, which we got, du over the square root of u. And that's one like we did just a short while ago. But if we want to lose that minus sign, what can we do? Flip those over. Okay. So now remember, these are different u's, but we've already adjusted for that because we changed our intervals. So this is 1/3. I'll let you do the integration, blah, 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 plus 1/18, and that will be the integral from 0 to 1. I would not do it this way. I'd say u to the minus 1/2 du, because I don't like integrating radicals. I like to put them in exponential notation, right? And then from there, it's a piece of cake, right?
We still have to find the difference between first part is pi over 2 and 0.
Yeah, but yeah, you integrate this first. Antiderivative of u is
It's 2.
u squared
U squared
over 2. Yeah, okay. And plug in the 1/2 and the 0. 0 I could do, do that. I mean, pi half, not 1/2, pi half. So that would give you a weird number, but it's fine.
Okay, don't we plug that cosine?
What's that?
I was confused with that. The u equal to inverse cosine.
Okay, yeah. But we don't have to go back and do that. If this were an indefinite integral, you have to do that. But with a definite integral, once you change your limits to be for u, forget about the cosine. You're just doing it with respect to u. Now that's where the pi halves came from, the inverse cosine, but you're just doing it with respect to u now. That's the beauty of changing those limits, that you don't have to go back like that.
Okay. Okay, I see.
Now remember, and that's why I said, it's really not nice to use u on both of them, they're representing different things, but it's really just a dummy variable. If you change the limits here for that u, and change the limits here for this u, you still can do it.
We don't have to go back to
You don't have to go back. If it was indefinite integral, yes you would. Definite integrals, that's why they're so nice. Just change the limits, calculate from there.
Then I have to go back and redo my other stuff.
Okay.
Because I was confused.
See how much you're learning on this test?
Yes.
Yes, isn't this good? You're saying, thank you, right? I knew you were. Okay.
Every time I do,
Uh-huh.
That's why, I don't know, because now I'm getting to know.
Okay. Well, that's then makes it worthwhile. All this struggle is worth it, right?
Yeah.
Yeah, right. I knew that enthusiasm when I heard it. Yes.
So,
Now that's the beauty of using your definite integrals. Once you get into a new variable, just change the limits and just deal with that variable. Don't mess with the others anymore. Indefinite integral, yeah, you have to go back and change it. Yeah. Any other questions? All right. Furthermore, nine B. Oh, okay. We were doing 9A. All right. What I'm going to do is okay to erase this one. All right, to erase this one. Okay. 9B. Okay, let me put this aside for a minute. 9B is the integral from 0 to 1/2. Oh, 1/2 ln3. That's your limit, upper limit. This looks pretty, doesn't it? Your inverse, your thing here is tangent, inverse tangent of e to the x over e to the x plus e to the minus x. And all that is times the dx. I believe so. It seems wacko, but that's the most complicated thing. So I think that's how I would start. Yeah, I may be wrong. We may find out. Let's try it. Let u equal, and what do you say? Inverse tangent of e to the x. Is that what you're saying? Okay. Then du would be equal to what? And here we. All right, we're back in the back now, right? Inverse tangent. Oh, that's integrals. I want the derivative. Yep, that would be 1 over 1 plus x squared. But our x squared there is e to the 2x, right? Because your x here is e to the x. That's why you might want to do another substitution first. I don't know. It's up to you. And then that would be dx, right? Now, that doesn't quite, sorry. Nope, I'm wrong, too. We have something else in there, don't we? We have an e to the x. Because the inverse tangent, the derivative of the inverse tangent would be 1 over 1 plus e to the 2x dx. But then you've got to do a derivative of this. The derivative of that is e to the x over d. Okay, times dx. You see, chain rule, you have to do a chain rule there. Now, this is, okay. Okay. Now, what I'm going to do here, this This is a trick. Okay? Y'all don't mind tricks, do you? Okay. Because this doesn't look like what we got up there, what I'm going to do is multiply numerator and denominator by e to the minus x. That's legal, isn't it? E to the minus x is never 0. It's always positive. It could get close to 0, but okay. So, the numerator would become what? E to the minus x times e to the x. E to the 0, and what is e to the 0? 1. So that's a 1 dx over, and what's your denominator become? E to the minus x plus you got it. And look what our denominator is up above. Almost exactly that, just flip the sides on the add-ins, and you got exactly that. So that is our du. Right? Okay. So this becomes the integral, but we got to plug in when u is equal to, when x is equal to 0, what is u equal to? See the x here, the dx is going from x equals 0. So when x equals 0, e to the 0 is, e to the 0 is 1. Okay? So inverse tangent of 1 is? Okay, it's 45 degrees. Usually you use root 2 over 2, right? Yeah. I'm sorry, pi fourths. I was telling you what it was. Yeah, it's pi fourths. Inverse tangent. Let me see if I'm saying that right. Yeah, inverse tangent would be pi fourths, because that would be your angle. So you're going from pi fourths down here when x is equal to 1/2 log 3. Okay? Well, the first thing I would do probably is change that to log of 3 to the 1/2. In other words, the square root of 3. The log of the square root of 3, right? That's another way to write the upper limit, right? Okay. Here's what I'm doing. 1/2 log 3 by the rule for logarithm is the same as log 3 to the 1/2 power. Okay, so that would be log of the square root of 3. So 3 to the 1/2 power is that. Okay, now the reason I did that, we want to do u equal inverse tangent of e to the log 3, e to the log square root of 3, and what would that be? Inverse tangent of it's the square root of 3, right? E to the log, those are inverse functions of each other. They undo each other. And what is the inverse tangent of square root of 3?
It's going to be pi over 3, right?
Pi over what?
3.
Pi over 3? I have to stop and think about it a minute. If that's pi thirds, then I didn't draw this very well. I think it's pi 6, isn't it? Because that'd be, oh, maybe not. You're right, pi thirds. I'm sorry, I drew it poorly. Yeah, if this is pi thirds, which is about 60 degrees, okay, then that would be 1, that would be square root of 3, and this would be 2, right? Yeah. So that would be, so this would be, inverse tangent of that would be pi thirds. So our upper limit would be pi thirds. Okay? All right. Now we plug in. U is in the numerator. Your du is precisely that. So that's the rest of your problem here. So this would be u du. And now, again, all you do is solve that for u. You don't have to go back. Okay, got it? Any others? Okay. All right. Want me to clear this? Y'all got it? You got it? Okay. Number 10, calculate the definite integral from 0 to pi halves of inverse sine of cosine x dx.
So can we get the u equal to cosine x?
What's that now?
U equal to cosine x. No.
Okay.
It's like
Right. Here, I think you might be able to, but then your du is equal to minus sine x dx.
yes.
And that's not anywhere in the problem.
Yes.
Okay. So here's what I suggest on this one. Draw pictures. Okay. Let's draw what we're given an x here. That's some angle, right? Okay. So let's just draw some old angle x. Okay. This is your angle x. Now, I kind of hate that because I like to call my horizontal thing x, but I can't because that's my angle now. So let's call these something else. We could call this A, B, and C maybe, right? So when we're talking about cosine x, that would be what? B over C. B over C. Now, what you're doing here is the inverse sine of B over C. Now, oh, and by the way, mine doesn't look like it, but that is supposed to be a right angle there. Okay. Now, the inverse sine of B over C. This is a number. Ratio of these two numbers is a number, right? Okay, it's less than 1. Because B shorter than C. Okay. So the inverse sine is going to give you an angle. The angle whose sine is B over C. So what do you want to name that angle? You can let it be anything you want to. Let's not call it X or A or B or C. Call it something else. What do you want that angle to be? Why not? Okay. Let Y equal that. Now express that in a different form. Y is equal inverse sine of B over C. That would be the same as saying the sine of Y is equal to B over C, wouldn't it? You buy that? Y is some angle. Now what angle would have a sine of B over C? Second? That angle up here, wouldn't it? This? No. That angle right there, that would have to be your Y. Because the sine of Y would be B over C, right? Opposite of hypotenuse. So that would be Y. Now how is that Y related to your X? If you have a right triangle, this is X, how is Y related to X? Those are, second, complementary angles, meaning, second, okay, what do they add to? Second, okay, if this is 90, okay, the 3 add to 180, this one's 90, so subtract that off, those two add to 90, which is pi halves, right? So you can say Y is equal to pi halves minus X, isn't it? They're complementary angles, they have to. So, what your inverse sine then is going to be pi halves. The Y is pi halves minus X. So it looks like now we have the integral from 0 to pi halves of Y, right? Which is pi halves minus X dx. And I don't think there's any substitution needed there. Just break that into two integrals and go from there. Right?
And we take the antiderivative of the part?
What's that?
Do we take the antiderivative of the middle part?
You do what? No, I don't hear well.
He said, do we take the antiderivative of 5 over 2 minus 6?
Oh, the antiderivative. Yeah, split this into two integrals if you want to. Antiderivative of pi halves would be, it's just a number, pi halves times x, right? Minus antiderivative of x would be x squared over 2, and then plug in those. Pi halves is just a number. You could call it
Okay, so
C.
this number,
or
and
not C.
we just get the x.
Yeah, and it's that number times x. Yeah. I mean, the other way you could do it is this. Split that into two integrals, and that would be pi halves times the integral from 0 to pi halves of dx minus integral from 0 to pi halves of x dx. You could do that if you wanted to. And antiderivative of dx is just 1 dx would be, antiderivative of 1 is x.
Yeah.
Yeah, okay. And then just pi halves times x. That's the same thing we got there, if you want to do it that way. Right? So there's really no substitution required in this one. It's just analysis of what your problem is. Now, maybe there's some way to do it with substitution, but I don't know what it is. I mean, to me, that would be harder than doing this. Draw pictures, make you see what you're talking about. Right? All right? All right. I think we're going to get it. Now, what is it y'all have against Theo, huh? Y'all ask all these questions about the test when he's not here. You don't ask anything about the test when he's... No, I'm just kidding. I'm just kidding. The last time it was just the two of you. But I put it all out here so he can get it. Okay? Okay. All right, to erase all this? Okay, oh, that's not what I wanted. Okay. Now, what we had been doing was indefinite integrals, integration by parts. Okay, so you had plus c's. This is 7-1, page 375, top of the page. We had been doing integration by parts with indefinite integrals. Okay? When we go to do that with definite integrals, remember if we didn't have the limits here, and you're just doing this, you find u dv, then do du and v, right? And then you do, that's equal to u times v minus the integral from of u prime v. Remember when we did that, okay? But then you'd always have a plus c at the end. If you have definite integrals, you don't have the plus c, but what you do, now this is the one place, and it's not any different. This is part of your answer, so you evaluate that from A to B. The product of these two variables, these two functions, plugging in x equals b in both u and v, multiplying those, subtracting from that u of a times u of v of a, okay? That gives you a definite number here, minus, and then this is a definite integral, and usually, remember, if we chose your u and v wisely, that would be simpler than this, and you should be able to get it done, right? Okay, so, and then that's a definite integral. That just gives you a number. You lose your plus c's, okay? So, let's do one of these, okay? So what I'm going to do is evaluate the integral from 1 to 3. Yes, ma'am. Hey. No, remember we had to change because I had a class. Then this class. Huh?
When is differential?
It's on Tuesday, Thursday from 9:30 to 11:10.
Have you gave out a test yet for it?
No, going to do that probably on I might give it out tomorrow, but if not, it'll be Thursday.
Okay, I probably have to come up with, because I get off at 4:30. Will you still be here?
On what, tomorrow or today?
Thursday, or Tuesday or Thursday.
Every day I'm here at 4:30. I'll put it that way, except Friday. Okay.
Okay, I'm sorry, 'cause I thought we had class there. I'm all screwed up.
No. Yeah, we had to change it. Yeah, okay.
Okay.
In fact, which are you in? Just that one class? Differential equations?
Yeah, and on Tuesday, Thursday, I have a computer class I take in the evening.
Right. Okay. So, but you don't have any other math classes, just that one?
Just
Yeah, it's Tuesday, Thursday, 9:30.
Cause I thought it was Monday.
It originally was on the
Yeah.
first schedule. It was, but I wasn't teaching it.
Yeah.
It was staff because I was afraid, and it wound up that I had more people in that than this, but I needed to teach this because they needed to graduate.
Yeah.
So we had to move it to Tuesday, Thursday, because I didn't have anyone else that could teach it. So
Yeah. So I should be here tomorrow around about 5. By the time I get off and get down here, it'll be about 5.
okay.
So what time do you leave?
Usually on Tuesdays, I've got to leave by 5:15 because I have to be in Homewood before 6.
Okay.
But I can leave it for you somewhere if you're not
You
here.
can leave it for
At
me.
the front desk?
Yeah, that will work.
Okay.
If you
Why don't you call? My office hours tomorrow are from 12:15 until 4:45. So if you just call, and like I said, I'm usually here till 5:15. Call and let me know if you're running late or whatever, and that way I'll let you know if I got the test ready or not. I haven't gotten it typed out yet. I've picked out most of the questions, but I haven't typed them out yet, so I've got to do that. So be sure to call me. That I don't want you to make a trip up here and I don't have it.
Okay.
And that way, if you're running a little late,
This was my day off from,
yeah,
So I was like, hey, I thought you come to class. So I was,
yeah,
So,
okay, all righty.
Thank you.
Sorry about that. I hadn't seen her in a while, so I wanted to make sure I called her before she left. Okay. The integral from 1 to 3 of log x dx. Okay. Now this is the funny kind of problem. Okay. You got to figure out which to be the u and which to be the dv. Remember, this is integration by parts. Okay. Okay, and the dv has to have the dx in it. This almost gives it away, right? Because if the dv is dx, what do we have left? U has to be log x. Okay, so let u equal log x. Okay, then du is equal to 1 over x dx, and v would be equal to yeah, right. Is what? No, you're not taking the derivative, you're integrating the dv. When you integrate dx, what do you get? That would be 1 dx. Integrate that and you get? No, you're differentiating. Integrate. Okay, 1 is the same as x to the 0th power, isn't it? Okay, and if you're integrating that, what would that give you? X. Exactly. If dv is equal to dx, then v must be equal to x, right? You don't have to do any plus c's with this because we've got our limits there. Okay, and what's the next part? Once you've determined this, and what I'm going to do is erase this over here because I need that space. This would become, once you figured out what your uv and dv is, you do u times v, which is the product of these two, which would be what's the product of the u times v? I would do it v times u. No, okay, don't do that. That's why I say I would write it v u x ln of x. Okay, one times the other. Sure enough, if you write it the other way, log x times x, you might think it's log of x times x. That's not what it is. It's log x times the function x, which is clear if you put it x log x, right? Reverse the order, just to make it clear. But you're going to evaluate that from 1 to 3. We'll come back and do that in a minute. Minus, and then the bottom line here. And what's that? The integral from 1 to 3 of what? The VU prime. VDU. What is V du? Here is V, x. Du is 1 over x dx. What's x times 1 over x? 1. 1 dx. The integral of dx. From 1 to 3. Okay? Now, I'm going to scrunch this up a little bit because I took way too much room here. Okay, going to compress this a little bit. dv is equal to dx. That's what I had. Okay, so let's evaluate that from 1 to 3. That would be, plug 3's in and you get 3 log 3 minus, say again? I can't hear you. Minus what? 1 log 1, right? What's log of 1? 0. Okay, forget that. That's a 0. Okay? Minus, now we have to integrate that. What do you get there? Antiderivative of dx. X, okay? This will be x evaluated from 1 to 3, okay? So this will be 3 log 3 minus 0 minus 3, okay, if you put it in parentheses, minus 1, right? Because it's minus, evaluate those two, but you got a minus for the bottom one. So this would be 3 log 3 minus 3 plus 1. That's 3 log 3 minus 2. Right? Let's see if they got, oh, look at that. They got it right. Good for them. You see how that works? All right. Let's see if they did that. I don't think they did. No, they didn't do anything on that. You just, no PowerPoint to help us here. Okay?
So we don't have to give the value of 3 ln 3?
What's that? Oh, no. If you wanted to write down approximately what that is, it's fine. Another way you could have expressed that is, remember the rule of logarithm, that would be the same as log of 3 raised to the 3 power. That would be the log of 27. So if you wanted to do the evaluation, you could do that, or you could just do 3 times log 3 and evaluate it that way. You get the same answer, subtract 2 from that. So log of 27, whatever that is, minus 2, you can get an approximate answer, a decimal answer. But you can leave it like this, leave it exact. Okay. Now if they say find it to the nearest tenth, then do those calculations. All right. Now, this next one is an interesting kind of problem. What I'm going to do, I'm going to work it out here because if I show you the PowerPoint, it gives away the answer. But here's what we got, the integral of e to the x cosine x dx. Okay. Now remember, when you have a product in here that you don't know how to integrate, then integration by parts is probably a good thing to try. What have you got to decide though? Which is going to be your u and which is going to be the dv. Now the rule is, pick the u, so when you take the derivative it gets simpler, which most of the time it does. But pick your dv so that when you integrate that, excuse me, sorry. When you integrate it, it doesn't get any more complicated. Well, guess what? These two functions are both ones that when you differentiate, they don't get any worse. And when you integrate, they don't get any worse. So you could choose either one of them to be your u and either one to be the dv. So you got to do that. Which one you want to be u and which one you want to be dv.
U equal to cosine x.
Okay, you want u to be cosine x. That's fine. Let u equal cosine x and dv is equal to e to the x dx. All right, the d's always have to stay together. Okay, then du is equal to minus sine. Okay. Boy, the sines and cosines, remember, when you take the derivative, they go one way. When you take the integral, they go the other. You're doing both of them here, so keep them straight. Derivative of cosine is minus sine x dx. And v would then be what? E to the x. Perfect. Okay. Now, and is this an indefinite integral? Yes, it is. Okay. So, what is that one going to be then? Well, you do the product of u and v. U you picked, v you just determined, so what would that be? E to the x cosine x, and since this is an indefinite integral, we don't do anything yet, minus the integral. Yeah, you do your bottom line. In fact, it actually is a plus, because here you have a minus and there you have a plus, but you had a minus because of the subtraction here, so that becomes a plus e to the x sine x dx. Okay? Now, where do you go from here? You're no better off or worse off. You still can't evaluate that integral, so we do it again. Now, you can call them something else if you want to, but if you don't mind, leave it as u and. This is fine. Not going to worry with that. What we have here is, let's do the same way we did before. Let u equal something and dv equal something dx. Which way did we go before? We let u be the trig function, so let it be again. This time it's sine x, okay? That makes the dv e to the x dx. Then du is equal to cosine x dx, because that derivative of sine is cosine, and v is equal to e to the x. Okay, now we plug in. Now we already had, remember, don't lose it, e to the x cosine x, right? Here we're going to have a plus, and now we do this product, e to the x sine x minus the integral of the bottom line here, and that is e to the x cosine x dx. Okay, remember all this was equal to e to the x cosine x dx. That's what we started with, and that's what we've got so far. Are we running in circles? We're back to the same integral we had before. And we aren't any closer to solving it, right? Oh, but we are. Because what you can do is add this integral on this side to this. Right? So let's add the integral of both sides. Plus the integral of e to the x cosine x dx plus integral of e to the x cosine x dx. Okay, these add to 0, so this gives you 2 times the integral of e to the x cosine x dx is equal to e to the x. I'm going to factor this if it's okay. Cosine x plus sine x. I'm just tired of writing so many e to x. Okay, and then let's divide by 2. And that will give us the integral of e to the x cosine x dx is equal to e to the x over 2. You don't have to write it this way, times cosine x plus sine x plus c. You have to do a plus c because of indefinite. Okay. Now this may not be the form they do it in the book, but let's see if it's close. Yep, they say 1/2 e to the x times cosine x plus sine x. So they did the 1/2 e to the x and then did the rest of it. So it looks like you're not getting anywhere, except you wind up with the same integral on both sides, add them to both sides, and then divide by 2, and you've got your answer. Okay? Without ever actually calculating the integral, you did get what the value of the integral was for whatever x you put in there. So, as going in a circle, it sure feels that way. All right. Now I'm going to go to their slide, see if I had done this. Oh no, it wouldn't have been too bad. I was thinking they were giving you the answer, but they didn't. Here was our first step. That's the problem we were given. Now they did it. No, they did it the same way we did. Okay. They let u be cosine x, d prime be e to the x dx. If you had chosen them the other way, you still get the same answer. Okay. You'll have a minus and give you the plus, but it works out okay. So with this being our u, our dv is e to the x dx, so v would be e to the x, so there's your, this is your v, that's the u. Minus derivative of this would be a minus sign, so that makes it plus sine of x, e to the x dx. So this is exactly what we got before, but this is your minus of derivative of that. So, strange way to write it, but they is correct. Okay? And then they turn around and take the derivative of the second one. Do the second integral by parts, which is integral of e to the x sine x, doing it the same way. Let this be the u. dv is that, so v is equal to e to the x sine x, minus, this time it is a minus e to the x cosine x dx, which is exactly the same thing you had to begin with. So when you, well, they just leave off the rest of it. We've already done the rest. All right. Now, here's the next thing they're going to. I don't know. They do. Their choice of what to put on the slides is really strange in this book. They take you a little bit of the ways and then leave you hanging. Okay? And for some reason, I can't see my cursor, but I know it's there. This is example 6. No, it isn't. Okay. It's a slightly different problem. But let's just imagine, okay, in the old book, this is example 6, isn't it?
Yeah, and then they under that they said the evaluate.
Yeah,
X,
sine
yeah,
cubed of that. Oh, no,
no, X cubed.
x cubed of that. Okay. So we're going to do both of them. Yeah, yours says sine. So we'll do this one first and then do what it asks you, then we'll do what the new book says. Okay? So let's do that one. The first thing says evaluate this. Derive the reduction formula. Okay? Now they've done the first step. Okay? I wish they hadn't, but they have. Okay, which would you let be what?
Let
U equal what?
e to the x.
No. See that, yeah, you want it to be this one because this will get simpler the more you take a derivative. This stays the same the more you integrate. So do it the other way here. Okay, so what they do first is let, of course when I go to right, okay. So what they're going to do is let u equal x to the nth, dv equal e to the x dx. Then du is equal to what? N times x to the n minus 1. You see why? Yeah. N's just some number, okay? And v is equal to e to the x. Very good. Now, do this once. uv would be x to the n e to the x minus the integral from, this n is out front, that's just a number. The bottom line here is x to the n minus 1 e to the x dx. Okay? And that's exactly what they got up above. You see it? Okay. Now, what we would do is do it again. Okay? The next time, it would be, and you keep the x to the n, e to the x, minus n times, and again you would let u equal x to the n minus 1. dv, I'm clogging up for some reason. dv is equal to e to the x dx. Then du is equal to what? Okay, n minus, it's actually going to be n minus 2 times x to the n minus 2. Okay? No, is that right? No, n minus 1, I'm sorry. Yeah, I'm sorry. I was going the wrong way. Okay, n minus 1. I got all clogged and just tried to write something down in a hurry and messed it up. Okay, derivative of u would then be n minus 1 x to the n minus 2 dx, and your v again would be e to the x. Then you do your cross product again, and that would be x to the n minus 1 e to the x minus, I'll keep the minus down there now, and this would be n minus 1 times the integral of x to the n minus 2 e to the x dx. Okay. Now, oh man. Let's go up to the top. That'd be x to the n e to the x minus n x to the n minus 1 e to the x. Minus a minus is a plus, n times n minus 1 times the integral of x to the n minus 2 e to the x dx. And notice what is happening here. I'm sorry. Okay. Every time you basically wind up differentiating this time and time again until finally you're going to get an x to the 0th power and will stop. But e to the x's are in every term. So what is your, what they call the reduction formula? That would be e to the x is in every term, so let's get that out of there. And you would have x to the n minus n times x to the n minus 1 plus, you alternate signs here, n times n minus 1 times x to the n minus 2 minus n times n minus 1 times n minus 2 times x to the n minus 3. And you just keep on going down. Okay, so your reduction formula, e to the x.
How did you get the n times n minus 1
Yeah, that's
times,
this coefficient here.
yeah,
You keep doing that again every time. So your next step would be let u equal this, then du would be n minus 2 times x to n minus 3, and that's where that one comes from. Okay?
okay.
So you see, you keep, you break down another derivative every time, and every time it's by this. So basically, what we have here is our reduction formula. Okay. Okay. Is that, they leave it something like that, and I don't have your edition of the book. How do they leave it? Before they plug in.
They say evaluate the reduction formula for n 3 to 1, and then they came up with x to the q ex minus
Don't they have something that looks pretty close to that? They don't.
they just did the they just evaluated this one right here. They didn't do anything for that. They just give this is the formula how it
Right.
runs, and
Okay.
they evaluate
But
this.
here's what they say. Oh. Oh, they just do it one time.
One time.
Okay. So they just stopped. They do they factor out the e to the x? Or they leave it in there?
Just leave it in there.
Okay. So it's x to the n e to the x minus n x to the n minus 1 e to the x. Is that where they stop?
They start x to the 9, -1 e to the x.
Oh, they just leave it in the integral form, which is the last, okay, that was on the last slide. They just do it And they, okay. All right. I thought they wanted a reduction formula. Okay. Then they say, evaluate the integral. Oh, here it is. This one right down here. They stop right here. Right there. Okay. All right. Now, I've taken it a little further. Okay. Then they say evaluate the integral of x cubed e to the x dx. Is that the one they asked for? Is that right?
Yes, sir.
Okay. So what we would do, using the reduction formula we just did, I'm going to do e to the x. I'm going to pull that out. And what does that leave us with? It leaves us with x cubed minus 3x squared plus 3 times 2 is 6x minus, and you do it one more time, and that would be 6. Okay. Basically what you're doing, you factor out the e to the x, you have x cubed minus 3x squared plus 6x minus 6. You're alternating the signs every time.
Okay.
You see?
So we
Yep.
don't have to do like let the u equal like we
Yeah.
did before, but we just plug that value into that formula.
Right. And notice here, you start with that first term that you had here, x cubed. Now alternate signs, just put plus minus plus minus plus. Okay? Take the derivative of this 3x squared, take the, and then that's a plus. Take the derivative of this 6x, take the derivative of that, you get 6. Alternating the signs, so you got it done. Okay. Now we're going to do,
We have to put the plus c, right?
yeah, and then a plus, let's see. Yeah, and then you have a plus c. I forgot that, of course. Now, in the new edition, they did a slightly different one, okay? And let's do it for the new edition, so you'll see them both. Same type of deal. It's just that this time, what we're asked to is derive this reduction formula. The integral of sine n to the x, sine to the nth of x dx. Okay, there's no e on this one. Okay, I thought they would put one in, but they don't. Okay, now you have to come up with that. That's what we got, right? In your book too, right? Okay. So what are we going to do? Let what's that?
U equal to. Are you gonna put the u
Yeah. Let u equal
sine
sine to the nth of x and dv equal dx, right? Then du is equal to n times sine n minus 1 x times, yuck, I can't write. Okay, times cosine x, right? dx, and v is equal to x. Okay? Do your uv, so this would be equal to x sine to the nth x minus n times the integral of sine n minus 1 x cosine x dx, right? Okay. do something else now. What would that be? Let u equal what would it be? Sine to the n minus 1 x, and dv equal cosine x dx. Okay, then du is equal to n minus 1 times sine of n minus 2 x dx, and your v would be equal to negative sine x, no, it's positive sine x dx. The antiderivative of cosine is positive sine, right? All right, so what do we have now? This would be equal to x. Okay. You do the derivative of the u, but you do the antiderivative of the dv, right? That's why you do it that way. Now, and it should have put a parentheses here, just to make that a little clearer. So what do we have from the beginning? X sine to the nth x minus n oh yeah, we got these two. And what do we have there? I'll keep this on the outside. Sine n to the minus 1 x times sine x. That's just sine to the nth x. Okay? Oh, wait. I did something really silly there. There's no dx here, that's just sine x. Because you're taking the antiderivative of cosine x dx would be sine x. Right? Because when you take derivative of sine x, you get cosine x dx. Okay, so sine to the nth, okay, minus the n minus 1 times the integral of the bottom line here, and that would be sine n minus 1, because sine x times sine n to the minus 2x would be sine n to the minus 1 of x dx. Okay? So this would be x sine to the nth x minus n times sine. I'm sorry?
I was just asking, what about the cosine?
Okay, what cosine?
dv equals cosine x.
Okay, dv is cosine x dx. Yes. When you find out what v is, you get sine x.
Yes.
Okay?
But when we write
Then you do these two,
2
and then that's on the outside, and this is on the inside. Not this, these. This and that. So you only got sines there. Yeah. Is it time? Okay, I'm so sorry. We've run out of time. But if you follow that on through, you'll notice that you always wind up with n sine n, and then the next term would be a plus n times n minus 1, and you got that same integral again, and every time you do that, you get another. So basically, it's going to be sine. So I've left off my x here. Basically, you can factor out where did I get an x? Oh, yeah. Okay.
So we can take
No, I bite something up here. Forget this. We'll come back and do it next time. We'll start at the top. We just don't. I messed up. I wasn't paying attention to the book, and we'll start back at example 6. Okay. This was a little more complicated than the e to the x was. That's why they put it in the new edition. So forget this. We'll get that corrected